This lesson is going to start our topic on trigonometry. It's going to cover learning target 1 in this topic. I can use the Pythagorean theorem to solve for missing sides and right triangles. Notice that this learning target is on our scale sitting at a level 2. So it's foundational knowledge. After we do Pythagorean theorem, we're going to learn other things about special right triangles, trig ratios. We're going to start solving equations with those ratios, talking about the inverse of them, and then using some special laws of trigonometry. But today is going to just get us started with some good foundational knowledge so that you can understand what a level 2 is. So let's remind ourselves of the Pythagorean theorem. Pythagorean theorem works only for right triangles. It doesn't work for any others. It goes a squared plus b squared equals c squared. In another sense, this is the square of the legs of a right triangle is equal to the square of the hypotenuse of a right triangle. A and B are called the legs. It doesn't matter which side is A or B, as long as they are never ever the longest side. C has to always be the hypotenuse. It is the longest side of a triangle, of a right triangle. So what we're going to do is we're going to use these pieces and this formula to figure out missing parts of right triangles. So in this example, we have a missing side. The missing side is x. We're given an 8 and a 7 to use. We first identify what the a and the b and the c is. I always start by figuring out where's the hypotenuse. The hypotenuse is the longest side and it is across from the 90 degrees. So the x is the c. Now I know that 8 can be A and 7 can be B. Does it matter which one is A and B? No, as long as you know which one is the correct C. So these get plugged into A squared plus B squared equals C squared. Now our problem is going to say 8 squared plus 7 squared is equal to x squared. 8 squared is 64. 7 squared is 49. Rewrite the equal sign and the x squared. 64 plus 49 equals 113. At this step, sometimes students forget what to do about this square, or they think, oh, I have my answer, it's 113. But you need to do the opposite of squaring. The opposite of squaring is square rooting. So I need to square root both sides of this problem. I need to square root the x squared, and I need to square root the 113. So my x is going to be equal to the square root of 113. This comes out to approximately 10.63. That is how you figure out the missing hypotenuse. Now I'd like you to pause the video, try this problem in your notebook on the left side, and then unpause it to see if you get the same answer as me. If you do not get the same answer as me, raise your hand and call me over. The answer I got for this problem is x is equal to approximately 15.81. Again, call me over if you did not get 15.81. Sometimes you're not finding the largest side. Sometimes the largest side is given to you. In this problem, in this example, across from the 90-degree angle is our longest side. The longest side of this right triangle is 9. So in this problem, the longest side is given to us. 5 can be our A, and I guess x will have to be the B. Again, we plug it into a squared plus b squared equals c squared. 5 gets plugged into the A spot, x gets plugged into the B spot, and 9 gets plugged into the C spot. 25 plus x squared is equal to 81. I'm going to subtract 25 from both sides, and I end up with x squared is equal to 56. Now it's time to square root both sides. X is going to be equal to whatever the square root of 56 is approximately 7.48. So sometimes you add, sometimes you subtract. Be careful about plugging things in correctly, and don't think that the c is always going to be the x you're solving for. Go ahead and pause the video now and see if you can do this problem correctly. If you get the wrong answer, pause the video again and call me over so we can talk about it. The x I got was approximately 7.94 kilometers. Sometimes sides can be given to you in kind of unusual ways. Since we're going to be square rooting a whole lot using Pythagorean theorem, sometimes you might be given a side that already has a square root sign in it. So, let's identify the pieces. I have a 3, and it's going to be my A. 110 is my B. X, which is the longest side of this triangle, has to be my C. So let's plug in each of these pieces into A squared plus B squared equals C squared. So my problem is going to say A squared plus, then I'm going to write down a square root 10. I'm going to put parentheses on it because I'm going to square it because the formula says I have to square the B. I'm going to plug in an x in the C spot. 3 squared is pretty easy. That's 9. But then what about square root 10 squared? Well, since a square root and a square are opposite of each other and they undo each other, if you square root a number and then square it back, you're just going to end with a number. We don't get 100, we just get 10. 9 plus 10 is 19. Now it's time to square root to make the square, the exponent, go away. X will be equal to approximately 4.36. This is how you deal with square root signs that are already on one of the sides of the triangle. Okay, go ahead, pause the video, and give this problem a try. Okay, the x I got for the problem is 15.17. If you did not get this, raise your hand and call me over and let's talk about it. Otherwise, go on to the next example. Otherwise, go on to the next slide. So that covers the range of problems that you're going to see when using the Pythagorean theorem. Remember, today's learning target was learning target 1. Remember, today's learning target was learning target 1. This is only a level 2 learning target, which means it's going to lead up to our other learning targets. We have 6 to get through in this topic because it's a pretty big and important topic. Don't forget to hit the submit button so I have record of you watching the video.